That would not been good on my video. Okay, so now then, let's go to the next part. And this time, you're gonna actually express an expanded form. Right, so let's change the directions. Express in expanded form of log base 3m and log base 3n. So what we did on the problems before, you'll notice they were expanded out and this said add, so we multiplied, right? Okay, on this section, okay, they're gonna already be written together. So for example, log base 3 of m to the 4th and n to the 7th. Now keep in mind that an exponent goes in front, right? Now this is in condensed form, we're gonna write it out. What does multiplication mean? It means what? Addition, the property of addition, right? So the 4 is gonna start, so this is the same thing as 4 log base 3m plus, and then the 7 goes in front because it belongs with the n, 7 log base 3n. You wrote it in expanded form. You expanded the problem out. Okay, let's go to number 2. Number 2 gets a little star. It looks a little strange. If I give you log base 3 of the cube root of n squared. Okay, if we have to expand that, there's no multiplication and there's no division, right? So if we think about our property rules, we have the property of multiplication, property of addition, and quotient, right? So then we have property of division, which is subtraction. And the last one we have, okay, is the exponents, right? Is there an exponent here? No. Can you create one? What exponent could I change the cube root of n squared? Right, the rule is power over root. So if I wanted to rewrite this, I would say, okay, log base 3 of n, the power is 2 and the root is 3. So if I want to expand it, that gives me something to do with it, right? Because there's no multiplication and no addition. No division, right? Nothing. So now then I'm just going to apply that rule by pushing the exponent.
Camera is not.
It's still recording.
Okay, let me see if I can fix it.
It's with the.
Can I use the restroom, Michelle?
Just a second. Yeah.
Yes.
Wait, can y'all check and see if the Elmos are unplugged?
It looks good.
We would check by you, Hallie. Oh, there you go.
Oh, Hallie.
Okay, guys. Shh. All right, so if you're watching this video, sorry, we had some technical issues, but we're back on track now. So, guys, the point of this was, I can't expand this. There's nothing to do. So if you see a problem where you don't know how to expand it, usually it's because there'll be a radical, okay? Then go ahead and get that in the form of an exponent. Because then you can use the rule, the exponential rule, okay? And just push the 2/3 in front. So that's the same thing as 2/3 log base 3n. And now you've expanded it. Okay? So now let's move to problem number 3. Number 3 is going to say log base 3 of m squared divided by n. Okay, again, it's multiplication. What property, it's division. what property goes from division? If you're gonna expand it out, division is subtraction. But that m has an exponent, so it goes in front. So you actually write the answer then as 2 log base 3m minus log base 3n. Okay, number 4. Log base 3 is square root of m over n cubed. Okay, now let's look at this. It's division, which means the property is subtraction. But with this radical here, it kind of messes things up. Just like in problem 2, and you can start by this one also. If you have a radical, we don't know what to do with it, right? So to clean it up, let's put them in exponential form so that the exponents can go in front. So if you rewrite this, first of all, as log base 3, okay, and this is a square root. So how would I rewrite the square root of m? What does that turn into, guys? You have m to the 1/2 power. And then on the bottom, okay, n cubed is inside there, and the rule is power over root. So it's going to be 3 over what? 3 over 2. Now you can rewrite it. Okay, it's division. So in front of the first one is going to be 1/2 log base 3m minus, and with the n, the exponent of the n is 3/2. So you're going to write 3/2 log base 3n, which would complete your answer. Number 5. Number 5 is log base 3 mn squared. When you raise the power of something and they're in parentheses, remember the 2 applies to both. Remember that? The 2 applies to the m and the n. Don't forget that. Okay? So when you write it out, it's multiplication, so you're going to write it as addition. So it's the same thing as log base 3. Oh, I forgot my 2. So 2 log base 3m plus 2 log base 3n. The 2 applies to both. Okay, for number 6, log base 3, 1 over n. Okay, the directions of this problem were right in terms of m and n. So if I tried to write it just like it is, it's division. So I would say, okay, log base 3 of 1 minus log base 3 of n. That's not the rule. The rule says in terms of m and n. So it won't work like it is now. What have we resorted to every time when it didn't work? We used what? We used exponents on numbers 2 and 4. So you can use exponents again here. How would you write 1 over n? Yeah, n to the, what puts an n in the bottom? A negative 1. Okay, so if I rewrite this, this one gets 2 stars. If I rewrite this as log base 3 of n to the negative 1 power, then I can simplify it. The negative 1 gets pushed in front. So negative 1 log base 3 of n. You want to rewrite that. If it looks strange and you're trying to expand it, rewrite it with an exponent.
Do we have to write the 1?
No, you can just do negative. She asked if you had to rewrite the 1 right here. No, just negative log is fine. Okay, so now we have 2 different sections left. If these are where it gets a little strange. Okay, we've done properties, right? So now we're going to take all the properties that we've learned and we're going to apply them. So if I say let C equal, we're going to say every time we see a log base 3 of 10, we're going to let it equal C. Right? And we're also going to say that every time we see a log base 3 of 5, we're going to let it equal D. right? So our goal is to get everything written with log 310 and log 35. Because if I can write everything in log 310, log 35, I can use C and D. Because the directions say to express in terms of C and D. This is where the lesson kind of takes a turn until like the twilight zone. Okay, so this is where it gets kind of strange. If I give you a problem, for example, log base 350, your ultimate goal is to write it in terms of C and D. But before you can do that, it says express it in terms of C and D, okay? If you can write it in terms of log 310 and log 35. So your note here needs to be rewrite using 10s and 5s. That's your little note to yourself. How can you rewrite 50 using 10s and 5s? What's going to work? Because I've got log 310 and log 35. How can I rewrite it? What would it be? 10. So this is the same as 10 times 5. Because if I have that, we know multiply means add. So it creates log base 3 of 10 plus log base 3 of 5. And what's the value of log base 3 of 10? C. And the value of log base 3 of 5 is D. So the answer then, in terms of C and D, is just C plus D. Tonight, if you start your homework and you get confused, the part of the video you might want to rewatch would be the end of this one. Okay, here's number 2. I'm going to ask for log base 3 of 250. How can I write the rule for this? If you want to use terms of C and D, I need to rewrite log base 3, but instead of 250, I want 10s and 5s. Okay? Now, I know 10 fits in here because it ends in a 0. So I'm going to rewrite this to start off with as 10 times 25. So my 10 is good, but I need to rewrite it with only 10s and 5s. What way? You can manipulate 5 any way you want to get to 25. So what would you use? 5 squared, because it's okay to have an exponent, right? It just pushes in front. So this is the same as 5 squared. So what you have now, basically, if you don't see that, is log 310 times 5 squared. Well, times means add. So you've got let's do the 10 first. Log base 3 of 10 plus, and on this 5 squared, the 2 goes in front. So 2 log base 3 of 5. Well, log base 3 of 10 has a value of C. And how many log base 3s of 5 do I need? 2, so plus 2D. Okay. So now then, the reason you did only 2 of those is because now I'm going to show you how to do it with numbers. Okay? So if you take that same exact idea, okay, and I give you log base 8 of 4, but instead of giving you a letter, I'm going to tell you the answer to this. It's 2/3, we've discovered it before. But if I tell you that to get from 8 to 4, the exponent you need is approximately 0.67, okay? And then I'm going to tell you that log base 8, 3 is approximately, in other words, the exponent to get from 8 to 3 is approximately 0.53. Right, so those are the 2 things. Then your job is to find the following. In other words, if you can estimate, kind of, that log base 8 to 4 is 0.6 and log base 8 to 3 is 0.5, you can actually answer a bunch of problems. The same way we turn them into C and D, we're going to turn them into answers. Okay, so let me show you what I mean by that. So for number 1, log base 8 of 9. Now, just like before, we rewrote everything with 5s and 10s. You'll notice all of these are base 8, base 8, base 8, base 8. What do you think I'm going to rewrite 9s with using? 3s and what? 3s and 4s. You're going to rewrite 9 using 3s and 4s. Okay, how can I come up? I use any operation on a 3 and a 4 to come up with 9. What do I need to use? 3 squared. I'm not even gonna need the 4, that's fine. So this is the same as 3 squared. So if I was gonna expand that, that would be 2 log base 8 of 3. Do you agree? So if I wanted to find the approximate value, what is the value of log base 8, 3? What value is that? It's what? 0.53, isn't it? So that means I want 2 of 0.53, which gives you an answer of 1.06. Number 2. If I say log base 8 of 4/3, thank you. My goal is to rewrite my problem with 4s and 3s. It's already in 4s and 3s. So this one's easy. He just wants me to solve it. I didn't have to do any extra work. Division means subtraction. So I've got log base 8 of 4 minus log base 8 of 3. Well, I know the value approximately of both of those. So this means 0.67 minus this value is 0.53, which is going to give us 0.14. Okay, we have 2 more. Number 3. If I give you log base 8 of 2, log base 8 of 2. Now, I need to rewrite 2 using 4s and 3s. What can I use there? 4s and 3s. You can do any operation you want. What can I do to 4 to get? What can I do to 4 to get 2? Yeah, what can I do to 4 to get 2? Take the square root. So let's rewrite this then as log base 8 square root of 4. And I'm going to use the 3. Okay? So then, this is the same as log base 8 of 4 to the what power, guys? 1/2. What's it do to the 1/2? It's going to push in the front. So 1/2 log base 8 of 4. I know the value of log base 8 of 4 is 0.67. So 1/2 of 0.67. Or in other words, you're going to take 0.67 divided by 2 or whatever, and you end up with 0.33 or 0.335. Okay, last one. Log base 8 of 16 over 3. You're going to want this one. It's division, which means it's going to be a subtraction problem, right? How can I get, what am I going to do with the 16? What's a way to get 16 using 4s and 3s? So this is the same as 4 squared. And the bottom is already okay. So if you rewrite division means subtraction, you're going to have 2 log base 8 of 4 minus log base 8 of 3. Earlier that would be like 2c minus d, remember that? But this time we have a value. So we want 2 of 0.67 minus 0.53. When you do the math, you get 0.81. Okay, so that's the last one for now.